All right, so we're going to kick it up a notch. Sorry, we're going to move on to lesson 2-4. And now what we're going to do is to make our multi-step equations have even more steps to solve. So we're going to solve equations, and one of the main things that you're going to be seeing, you're going to solve equations with variables on both sides. So today's date is 11/6/15. Now, in addition to that occurring, our old friend, Mr. Distributed Property, may show up as well in our problems. And then we also are going to come across some weird problems. Okay? So let's kind of go through just a process. So let's do a problem together, and we're going to do it on the notes side, but what we're going to do is, as we do each step, we're going to write down what we're doing. Okay, so what do you think we'll do first? I'm going to give you the worst case scenario. Okay, so I'm going to give you the hardest problem with the most amount of stuff in it. Let's get this one. So this is on the note side. I know that seems kind of weird. We're going to solve this problem. 6 times the quantity, 5 minus 3, equals 1/3 times the quantity, 24m plus 12. Okay? So again, what we're going to do is, as we do each step, we're going to write down what we're doing. So what we're doing on the right side is going to be kind of your process that you're going through as you see these problems. And then Monday I'll have a really good review for you on all of this. So 6 times the quantity, 5m minus 3, equals 1/3 times the quantity, 24m plus 12. So what's the first thing that we need to do to start solving this particular equation? Okay, Brandon.
Do your operations.
What do you mean by that?
The parentheses first.
Okay. Inside the parentheses, I have 5m minus 3. They're not like terms, so I can't do that one. On the other side, I have 24m plus 12. So I can't do what's inside the parentheses. So I got to come up with another way of dealing with those parentheses. Patrick.
Distribute.
This is when we're going to distribute. Now, watch carefully because I'm still seeing mistakes as I'm grading through the test. You have 6 times 5m. What does that give you? 30m. What sign do you see coming up? Yeah, so I have a positive 6 times a negative 3. What's that going to give you? A negative 18. Now I'm done. Go to the other side. This one gets a little trickier because of the fraction. What's 1/3 times 24m? 8m, because 3 goes into 24 8 times. And what's 1/3 times a positive 12?
4.
I heard Patrick, I think, say it. Positive. Positive. We got to put a sign in. Was that you, Liam? Sorry. My ear just hears back. So 3 goes into 12 4 times. This tells us distribute first to remove parentheses. So if your question doesn't have parentheses, then you would be skipping this step. Okay? Now what? What do you think we would be doing next? Philip. The reality is, I've got variables on both sides, but I need them only on one. And since our answer wants the variable to be on the left, makes sense to take them to the left. Okay? So next is we're going to do inverse operations. To get variables on the left. Now my question is, could you still get the right answer if you took all your variables to the right? You could. It is possible to do that, okay? But again, then you're going to have to do symmetric property at the end so that your variable is in the right location. So I'm going to do that math, and I get 22m minus 18 equals 4. Now what? Kate, what would be the next step? Okay, so we're going to do inverse operations. To get constants on the right. And adding 18 to both sides is what we need to do. That gives us 22m equals 22. All right, now what? All right, Liam. Oh, sorry. I thought it. There you go. So next step is to do inverse operations. To isolate, or let's do it this way. Let's say this. To get rid of the coefficient. So we divide both sides by 22, and we get m equals 1. Okay? Now, let's go back and let's add a couple things. Let's go back to step 2. When I say do inverse operations to get variables on the left, what operations are you going to do in that step? You've got 4 choices: add, subtract, multiply, divide. Which operation or operations would you be doing in step 2? Patrick.
Subtraction, property, recall.
Okay, that's one. What's another one?
Addition, property, recall.
So when I'm trying to take something from one side to another, it's adding or subtracting when we're dealing with the constant and when we're dealing with the variables. So on the second one, or step 3, same thing. We add or subtract or add, doesn't matter. But on the last step, to get the coefficient to go away, what operations are we doing at that point? Brandon?
Multiplication and division.
Yeah, we would do multiplication or division. So remember we had talked about in general, we're going to add or subtract first to get constants together, same thing to get variables together, and then we would multiply or divide to get our coefficient to go away. Okay? So let's go to the odd page where we're going to do some examples, but I am going to give you a couple of interesting examples. Directions are going to say solve. So now that we've got a pattern down what we're going to do, let me give you an easier one that doesn't have parentheses. So this one should be simpler to do. So I have 5a plus 2 equals 6 minus 7a. So let's see, it was green, blue, purple. All right. So first thing, do I have any parentheses? Yes or no? No. Okay. So we said second step, let's deal with the variables. So how do I get all the variables on the left? What am I going to do, Jack, to both sides? I believe you're Jack?
Oh.
Yes. Okay.
Something else.
No.
You would add
What am I going to add?
7,
Just 7?
A.
Okay, it's got to be that whole term. We're going to do opposite or inverse operations with the variables to get them to the left, so that means I'm going to add 7a to both sides. That gives me 12a plus 2 equals 6. Okay? And then the next step, Bianca?
Subtract 2 from both sides.
Very good. I'm going to subtract 2 from both sides. And that gives me 12a equals 4. Okay? And then next step, let's see, Savannah?
You do inverse operations
Okay.
to get the variable, so you would divide by 12.
We're going to divide by 12 on both sides. Now, 12 doesn't go into 4 evenly, so I'm just going to reduce my fraction. They both have a 4 in common. 4 divided by 4 is 1. 12 divided by 4 is 3. So my answer is A equals 1/3. Okay, so I had one less step than if there were parentheses. That's not so bad, right? All right, so let me give you a couple weirdos, because you might be seeing these on homework tonight. So we have 5x plus 5 equals 3 times the quantity 5x minus 4. Ooh, outside the parentheses minus 10x. Ooh. Huh, we may have to go back and add a step to our notes. Okay. So what's the first thing we know to do in this problem? Yeah, we're going to have to distribute to get rid of the parentheses. Let's see, I forgot what color that was, red. So I'm going to distribute, and I get 3 times 5x is 15x. And then I have 5 times negative 4 gives me a negative 12, excuse me, and then I still have the minus 10x. So how is this problem different than the other two? What do you notice is strange about this one that we didn't have an issue with before? Alicia.
It has an extra variable instead of 2, it has 3.
Yeah, in fact, if you notice, instead of there being 2 terms per side, one side has 2 and one side has 3. That says there's probably some math we can do on that side. So if you notice, these two both have an x involved. So they're like terms. So a step we may need to add is to combine like terms on a side. And I'm going to tell you a little hint. At the end, no more than 2 terms per side before doing inverse operations. So before I can start getting variables on the left and constants on the right, I got to make sure that I have no more than 2 terms. If you don't take care of this step, then you're subtracting 15x from both sides, you're adding 10x to both sides, and it's doubling up the time. So it's really, best idea is to combine things together. So we didn't do anything to the 5x plus 5, but now what's 15x and then in front of it is a negative 10x? What's 15x and negative 10x? 5x, okay? And then we have minus 12. So again, that's how I got this value here, was 15x minus 10x. Now you can rearrange, use the commutative property, and then group the 15x and the minus 10x if you need to do that extra work. Okay, so now I'm ready, down to no more than 2 terms per side, no like terms left. I want to get my variables to the left. So what math am I going to do to both sides? Nico.
Add 12.
That's dealing with constants. I want to deal with variables first. So how do I get the variables together? How do I get him to go that way? What's the inverse of a 5x? No? That's not how we jump ship with things from one side to the other when we are dealing with getting like terms together. We're going to have to go over an equal sign. So go back to your notes on the note side and look at your step 2. What does it say? We're going to need to subtract or add. So I've got a 5x. So what math would I do to make him disappear off the right side? I'm going to subtract. So the sign that we're going to use doesn't come from what operation's happening in the problem. It's what's the sign of the number that we need to deal business with we're going to do the inverse to that sign. So the inverse to a positive sign would be a negative sign. So I'm going to subtract 5x from both sides. And then something totally bizarre happens. We get 5 equals negative 12. So my question is, when does 5 equal negative 12? Never. Okay? At this point, we are done because this is what this is telling us. There's not a single value I could substitute in for the variable and get an answer that makes sense. So what we say for a problem like this is no solution. Since 5 can't equal negative 12, we say no solution. And remember, I think we talked about this before, there was a symbol we could use. And it was a 0 but with a slash through it. So either one of these is an appropriate way of saying I can't solve this problem. So again, interpreting. There is no value for the variable that makes this equation true. And remember, that means what's on the left equals what's on the right. We talked that back, I think it was beginning of chapter 1. Okay, so that's what's unique about this problem. All right, so let's do, this is our second of 2 weirdos. 3 times the quantity, 2b minus 1, equals, oh sorry, not yet, minus 7, equals 6b minus 10. Okay, job 1 is to do what? We're going to do the distributive property. So 3 times 2b, 3 times 2 is 6, and the b comes along. And then 3 times negative 1, that's negative 3. And then outside was the negative 7. And over on the other side is just the 6b minus 10. Okay, so this one is kind of like the last one. How many terms do I have on the left side? 3. So what I have to do is look for some like terms and combine them up. So what are the like terms on the left side? Negative 3 and negative 7. You got to watch your signs. So what's negative 3 and negative 7? Negative 10. Now, look at what we have. What do you notice is kind of unusual here? They're the same on both sides. But let's say we didn't see that. Let's continue on. What am I going to do to get the variables on the left? Anybody? I can't add 6b because he's already positive. I need to do the inverse. So I'm going to subtract 6b from both sides. Now I'm going to do something a little different. You know how we've been doing this one step at a time? Well, because the answer I get for the variables has no effect for the answer I get on the constants, I can do both of those steps at the same time. So here's another way to solve the problem. What's the opposite of subtracting 10? Add 10. Well, look what happens with everything. This equals 0, this equals 0, this equals 0, this equals 0. And the question, and the answer ends up being 0 equals 0. So the question is, oh, come back here, my little friend. So we have 0 equals 0. And I guess my question would be, when does 0 equal 0? When is this true? Yeah, this is always true. Which means that every single value that I could think of for the variable would make this true. Now, we used a word back in chapter 1 that represents the situation. Do you remember it, Johnny? Okay, that is a way we can write our answer. But think about it. There's a property that we talk about that when we do math, we end up with what we started. Okay, what is that property called? Brandon, you remember? Not reflexive.
Symmetric?
Not symmetric. Okay, Lainey? No, that says if you multiply by 0, you get 0. Okay, If I add 0 to 5, I get 5. If I multiply 5 by 1, I get 5. Those properties are called the identity properties. The identity of the value doesn't change. So we do have a word we can use for this, is we can say this is an identity. And an identity means all real values work for this equation. Meaning, every single number that exists is a solution. So one way we can write the answer is using the word identity. The other is, let's get a little bigger here for you guys. The other one is what Johnny Ray said, all real numbers. So that means fractions and decimals, positives and negatives. That's another way of writing the answer. And then the last way is I gave you a symbol for this, and that's kind of this cursive R. Okay, so that's another way to write the solution here. So we have answers where we get one solution. We have answers where we get all solutions possible. And then we have an answer where we get no solution. So all of those are available on your homework tonight.